percent increase and percent decrease problems appear in newspapers and on television quite often. A meteorologist might talk about a percent change in rainfall, for example, from one month to another and say, oh, there was a 10% change in rainfall from March to April or whatever. And in the newspaper, we might read about changes in unemployment or other kinds of issues. And so it's a very common situation to see percent changes. Let's talk about percent increase first. And suppose there's an automobile that was sold in 2001, and the price in 2001 was $18,000. And then in 2002, the price changed to $20,000 for the same model automobile. We'd like to calculate the percent increase in this situation. Now, we can relate this back to something that we've had before. Remember, we had a percent equation before, and that percent equation worked like this. It was what percent of some base is some amount. So it was percent times base is equal to amount. Now, when we apply the notion to our problem right here, the basis price, you see, is the original price of the automobile. And the amount here is the amount of the increase from one year to the next. So we're trying to find the percent of the original price, which is the increase. You see, what percent of the original price is the increase? So that's a way of correlating it back to something we've had before. Now, in this situation, we need to make the calculation for the amount of the increase, and we can do that pretty easily. Let's slide over here. The 2001 price, remember, was $18,000. The 2002 price was $20,000. The amount of the increase from 2001 to 2002 would be the difference between these two. So from $18,000 to $20,000, gee, that's an increase of $2,000. So the amount of increase is $2,000, and we need that in our equation for the calculation of percent increase. Now, here's what we're thinking. We're thinking, what percent of the original price is the amount of the increase? That's how we fill in here. And what percent? Well, it's in percent. Of means times. 18,000 is means equals, and then 2,000. And we go through and solve this. Recall that what we would do from here is divide on both sides by 18,000. That is, we would probably write this as 18,000 in, and we're dividing by 18,000, and on the right we have 2,000, and we're dividing by 18,000. Well, the 18,000s go out, and we're isolating the n as expected on the left. Here, this reduces to, well, we can kind of think of reducing like that, taking out those zeros. This is 2/18 or 1/9. But we want to write this as a decimal so that we can easily change to percent. So we would take this, now this, remember, becomes 1/9, so it's 1 divided by 9. And when we perform that calculation, it turns out to be 0.11111 forever. You see, it just goes on and on. Well, let's round this to the nearest whole percent. Now, we know when we change it to a percent, the decimal is going to slide 2 to the right. So it's going to be 11%. So this then is 11%. A lot of times it's important to write a statement of some kind that expresses what we're finding. We're saying here that there was an 11% increase in price of this automobile from the year 2001 to the year 2002. Let's put this in another context. A factory worker earns $8 per hour. He is given a 5% raise, and we'd like to find out his new hourly wage. He's making $8 per hour now. After this 5% raise, how much will the wage be per hour? You see, now, we're using the same idea that we used before, and it's the notion that we have percent of some original is increase. You see, and it relates all the way back to our percent equation. Percent times base is amount. The amount is the amount of increase, and the original here is the base, the basis idea And we saw it as the price of an automobile in the previous problem. But in this problem, we're given percent, and we're asked for another item in this group of 3 items. And the item that we're interested in is the increase. And this problem actually has 2 parts to it. We're going to make the calculation for the amount of the increase in hourly wage, and then we have to figure out the new hourly wage. Well, let's figure out the amount of the increase first. All right, and it's done like this. The percent here is 5%. We express it as a decimal. The original, the basis, the beginning amount, you see the beginning price, the original wage is $8 per hour. And we're calculating the amount of the increase. Is means equals, of means times, and away we go. We have 5/100ths times 8 is 40/100ths. And we're talking about money here, so this is 40 cents, and that then is the amount of the increase. Now, it's pretty easy in this problem to see what the new hourly wage is going to be. The old hourly wage is $8 per hour. We're experiencing a 5% raise, which is a 40-cent per hour raise, and therefore we add 8 with 40 cents. Well, we kind of understand that in this problem, but we're setting ourselves up to work more complicated problems. And if there's any confusion about what needs to be done in order to make the calculation for the new hourly wage, then I suggest that we put our ideas into a half mathematics and half word form. You see, we kind of describe what's going on using words and using mathematical symbols. And all we're doing is just intuitively describing what's going on. And this is what learning by concept means. It's learning by using the general idea in the problem that we have. And that transition allows us to go from, to think through a form like this very easily. We can think, well, let's see, how do we calculate the new hourly wage? Well, we take the old hourly wage and we add the amount of the increase and we have the new hourly wage. Doesn't that make sense? Go like this. Sure, it makes sense. And we can write that down, and I suggest that you do that. You might write this. You might say, well, we take the old wage, we add the amount of the increase, and we have the new wage. It seems very obvious when we see it in a form like this. But to go through the process of a confusion into a mathematical form which allows us to make the calculation, we write this down. All right, now it's pretty easy. The old wage, $8 per hour. The amount of the increase, 40 cents per hour. Add those together to find the new hourly wage to be $8.40 per hour. The idea of percent increase is related to one of the most fundamental ideas in business, and that's the idea of markup. To explain markup, though, let me set it up like this. Suppose I explain to you the way I would make money if I'm the proprietor of, let's say, a hardware store. If I'm the proprietor of a hardware store, then I would go out and I would buy items to sell. I would buy hammers and saws and lawnmowers and all manner of nails and other kinds of building materials. Okay. And I pay some amount for those, and let's call that amount a cost. All right, I take that cost and I say, in order for me to make some money, I have to add something to that cost and sell the item for more than I paid for it. So I'm going to mark it up. I'm going to add some money to my cost. And then I'm going to establish, therefore, my selling price. So here are the items. Here are the important items in establishing a selling price. I have a cost, the amount that is paid for an item like a hammer and saw and so forth. I have a markup, which is the amount that I add to that cost. And I have established, therefore, the selling price or the price that a customer pays for the item. So cost plus markup is equal to selling price. It's just one of the fundamental ideas in owning a business. Now, let's talk a little bit more specifically about this markup notion. You know, if I'm marking up, if I'm trying to figure out how much I want to mark up a hammer, I might say, well, you know, the hammer cost me about $10 and I'm going to mark it up $4, so I'll sell it for $14. You see, now I've established a markup amount for the hammer. But would I make the same markup amount for a lawnmower, let's say, as I would for a hammer? You might say, well, gee, the lawnmower cost me $120. Am I going to just mark it up $4 and sell it for $124? No, I can mark it up more than that. And what businesses generally do to make the whole situation relatively easy is that rather than say that the markup amount is some fixed amount of money for every product in the store, what they do is they say, well, let's make the markup, let's calculate markup by figuring a percent of the cost. So markup is calculated as some percent of the cost of an item. So markup is equal to percent times cost. And by the way, this this percent is often called the markup rate. The markup rate, and it is in the form of a percent. So markup rate in the form of a percent. Now, so that allows us then to, if we have a markup rate, we can calculate the amount of the markup and then calculate a selling price. So there are actually like two stages to the calculation of a selling price. All right, let's go through a problem. Soup costs a store owner 80 cents per can. The markup rate is 40%. We want to first calculate the markup, the amount of the markup, you see, and then we want to calculate the selling price. So what is the markup? What is the selling price? Now, often in problems like this, you may begin by just writing the information you know. We're given the cost per can of the soup and we're given the markup rate. Let's write that down, kind of in outline form. The cost is 80 cents per can. The markup rate is 40%. Now, to make the calculations that we're after, I want to try to explain this in a way that will allow you to intuitively go through the problems rather than trying to memorize formulas. You want to minimize the amount of memorization you do. You want to go through by general idea or by concept to get into the notion of a problem. So when you see the idea of cost, you see a markup rate. The general idea that you want to jump out at you is the notion of the amount of the markup. That is, the markup is found by taking some percent of the cost, some percent of the amount that we paid for this item. So you might write something down. You might jot something down like this. The amount of markup. Now, I am using this word amount just to emphasize that it's not a percent. You see, it's a dollar amount. But that amount of markup is equal to the markup rate, some percent, times the original cost. And you can just jot it down kind of like this. All right, so let's see. That this amount of markup then is, well, let's see, percent is 40%, and the cost of the item is 80 cents. So multiplying, we find that the markup is, this product turns out to be 32 cents. So the amount of the markup is 32 cents. Now, this answers the first part of the problem. The second part of the problem requested that we find the selling price. Now, the selling price goes back to just our fundamental idea of how money is made in grocery stores and other kinds of retail businesses. It is to take the cost, add the markup, and establish the selling price. And that's all there is to it. And you might want to write those items down. It is this, that the selling price is found by taking a cost and adding some markup And we have all of those items in this problem. So the selling price is, let's see, let's go back and look for the cost. Oh, it's 80 cents per can. And the markup we found here to be 32 cents. And adding, we find that that selling price then is $1.12. So the selling price of the can of soup is $1.12. Let's go to the decrease side. We've been talking about increase. We talked about percent increase, and then we talked about markup. Well, let's talk about decrease a little bit. Suppose we have a situation where the December telephone bill is $92 and the January telephone bill has dropped down to $60. In December, a lot of relatives were called and all of that kind of thing, let's say. All right, we'd like to make the calculation for the percent decrease. Now, percent decrease is related to percent increase in that we can go back to our basic percent equation in order to understand what this is all about. Now, remember, there was a percent times some original that gave some amount. Percent times original, percent times base, remember, was equal to amount. And when we talked about increase, it was percent of original, you see, turned out to be the increase. And now it's going to be decrease. So it's percent of original for our decrease. So it is, and I'm just going to jot down an idea here for relationship. And this is how you might start to cultivate some strategy for solution in your problems. But we know that it's percent of original is, and in this case, decrease. Now, before it was increase, but it's some percent of original is also decrease, you see. So, just a fundamental idea. Some percent of the original is either an increase or decrease, or an increase or decrease is some percent of an original. You see, so that's a fundamental idea to find what we want to find. Percent is what we're looking for here. And I'll just let N stand in for that. Of means times. Original, the original amount, the starting amount here, oh, that was the $92, is the amount of the decrease. The amount of the decrease. Now, wait a second. We don't have the amount of the decrease here. We have to figure that out. You see, it's not given to us, but we can figure it out pretty easily. The amount of the decrease is the difference between these two. The phone bill went from $92 to $60, and that's a decrease of, well, let's see, 92 minus 60 is $32. So the amount of the decrease is 32. And now we go through and solve as we understand that we would. This is the same as 92N. We're going to divide on both sides by 92. So we take 92N on the left and divide by 92. And on the right, we're also going to divide by 92. And these go out, and we find N then to be 32 over 92. Turns out to be approximately, and I'll write approximately here. I don't think this turned out to be exact, but it's approximately 0.35 and so on, and that is 35%. So the percent decrease from December to January for the phone bill is about 35%. When we talked about markup a little bit ago, we discovered that markup is related to percent increase. Now, we just talked about percent decrease, and it has a relationship in business as well, and it's the notion of a discount or a sale. So it's the idea that percent decrease and the notion of discount and the idea of a sale in a store all relate to one another. And the relationship is like this. If a store is going to have a sale, then they're going to take the selling price or the regular price of an item, and they're going to discount it somewhat. They're going to subtract something from it. And the amount that they're subtracting is called a discount. And the amount that's left over, that difference, is called the sale price. So regular price, or this is what we had called selling price before. So that's the regular price of an item in a store minus some discount is equal to the sale price. Now this discount is figured as a percent though. In fact, the discount is some percent of the regular price. And notice the relationship here between markup and discount. The markup, remember it was the cost plus markup equals selling price. And the markup was a percent of the cost. Well here, the discount is a percent of the regular price. So discount is some percent times the regular price. All right, now in this whole process, this percent has a particular name. Sometimes it's called the sometimes it's called the discount rate. Remember with markup, it was markup rate. Well, here we're talking about discount, and the percent here is called the discount rate. Let's consider a problem. Suppose we have an item that's selling for $7 and the store advertises a 20% off sale. What is the sale price of the item? We want to know the sale price of the item. Well, we really have two things to calculate here. We need to calculate the amount of the discount, and then we need to calculate the sale price. So we're going to calculate the amount of the discount and then the sale price. Now once again, I don't suggest that we go through and try to memorize a number of formulas here for this process. I think if we just understand the process, then we understand the arithmetic processes involved in making the calculations. All right, the first thing we might want to do is outline our information. We know the regular price of the item is $7 and we're given that the discount rate is 20%. Now, we'd like to make the calculations for the sale price, but first we have to find the amount of the discount. Now, the discount is some percent of the regular price, so we might just write that down. Discount is some percent of the regular price. And we know that that percent is the discount rate. You see, it's the sale percent. And that sale percent was 20% off sale. It was 20%. So we have 20%. The regular price is $7. Multiplying here, we find the amount of the discount to be $1.40. All right, that's the first thing we need to find, but we also want to find the sale price. Now, if the amount of the discount is $1.40, then that's the amount we're going to subtract from the regular price. So the relationship is this. It is that we take the regular price, we subtract the discount, and we have the sale price. That's all there is to it. The regular price is $7. The amount of the discount is $1.40. And the sale price then is this difference, and it turns out to be, well, let's see. I'm subtracting here, I get 0. 4 from 0, we can't take 4 from 0. We borrow from the 7, it becomes a 6. The one that we borrow makes that 10. 10 minus 4 is 6. Bring down that decimal point, 6 minus 1 is 5. So the sale price then is $5.60. Let's examine briefly here the relationship between the markup notion and the discount notion and how similar they are in the two processes. We know that cost plus markup is selling price, and that markup has a percent associated with it. The markup is percent of cost, percent times cost. You see, and so that's the idea, and that percent is some markup rate, it's called. And for the discount idea, it's regular price minus discount equals sale price, and the discount is some percent of the regular price. And the percent is often called the discount rate. In this chapter, we have talked about quite a number of related ideas. As a way of review, let's consider a couple of word problems. Here we have a problem that says the enrollment at Central High School was 1,245 students in 1997. In 1998, the enrollment increased to 1,494 students. What was the percent increase in enrollment from 1997 to 1998? Often in problems like this where there is a lot of information in the word problem. The toughest part is to set up the outline for what operations to perform to answer the problem. The operations themselves are relatively easy, but setting up those operations and understanding what to do is kind of tough. Now, to take the toughness out of that, though, you start with general ideas. Now, here we see in this problem that we're requested to find the percent increase. So we just want to write down fundamentally what we know about percent increase. And it's the idea that we can take a percent and multiply times some original amount. So a percent of an original amount is the amount of increase or decrease if we were talking about decrease. Now here we're talking about increase, but this is just a fundamental idea. And this is how you take the toughness out of word problems. You just start with a general idea and then build on that general idea. Well, with this general idea, let's summarize just a little bit. It says percent of original. You see, percent of original amount is the amount of the increase. And now we just fill in for what we know. Now we're looking for percent, and often we let a letter stand in for what we're looking for, but here I'm just going to maintain the word as what we're looking for. Whether you use the word or a letter really doesn't make any difference. So we're looking for a percent here, and the word of means times. Now the original amount, the original number of students is 1,245. The word is means equals. Now the increase refers to the amount of increase from 1997 to 1998 in this school. And here we have a calculation to make. And fundamentally, we understand that if we take the 1998 enrollment and subtract the 1997 enrollment, we'll get the amount of the increase. You see, you take the larger number and subtract the smaller one, basically, to get the amount that we increased from 1997 to 1998. So it's 1,494 students minus 1,245 gives us 249 students. So 249 is the amount of the increase. And at this point, it's a matter of doing a little simple mathematics to get our answer. We're dividing on both sides by 1,245 in order to isolate the percent idea on the left side. On the right, when we divide, we get 2/10. Now, we want to express 2/10 as a percent, so we'll move that decimal point 2 places to the right and tack on a percent sign. So the percent we're looking for is 20%. And now we write our answer. The enrollment at Central High School increased 20% from 1997 to 1998. Don't forget now that to begin this problem, to start the problem, you start with a general idea. And that's what jump starts and makes easy many, many types of word problems. Here's another type of word problem that we talked about in this chapter. It says Page's Bookstore uses a markup rate of 35%. What is the selling price of a book that costs $12.50? Well, we're talking about markup, we're talking selling price, we're talking cost. We might just begin by writing down the relationship between those ideas. We remember from our discussion that cost plus markup equals selling price. Now, do we have enough information here? We're trying to find the selling price. Do we have the cost and the markup? Well, we know the cost of the book is $12.50, but the markup, we only have the markup rate here. We're given a markup rate of 35%. We don't have the amount of the markup. Now let's talk about how markup and markup rate are related to one another. We would think this way. Well, markup is often expressed as a percent of the cost, and that percent of cost is called the markup rate. So the markup is some percent of cost. Now, let's figure out the markup in our problem. The markup then is, or is equal to, some percent of the cost. The percent is given to us as 35%. Of means times, and the cost of this book is $12.50. Well, now it's pretty easy for us to calculate the markup for our problem at hand. The markup is 35% or 35 hundredths times $12.50 or 12.50. And when we multiply, we find the markup to be 4.3 $3.75. Well, we're thinking about dollars and cents here, so we might round this to the nearest penny, which means that the markup is $4.38. Now we're ready to fill into our basic understanding of cost, markup, and selling price. But I think it's important for you to understand how the problem developed. We started with this statement of cost plus markup equals selling price. And that's what you should try to do on your problems. That is, write down a general idea and then build upon that idea. Do some thinking about the parts of the idea, you see, and build upon the ideas in order to figure out what mathematical manipulations need to be performed in order to make the various calculations. Well, let's go on with this problem. The cost we know is $12.50. The markup we just figured out to be $4.38. And those two together will give us the selling price. So when we add, we get $16.88 for the selling price of this book at Page's Bookstore.